Hello folks. Today will be the first of a semester's worth of videos, alright, for this section, otherwise known as Mathematical Structures 2, right, which means that if you were with me for spring 2021, you would be in one of these two for 114. You'll either be in IN or IN1, right? If you're not, alright, then perhaps you're in another section, but not with me. Anyhow, what I want to do is two things primarily. Walk you through basically the syllabus to explain the requirements of the course, and then we will begin with section 4.1. Hopefully this is visible and you can hear me from over here. The syllabus, let me see if I can, sorry, I have to kind of like dangle a little bit because of my camera. The syllabus is available online. It would look like this, and I'll point to it now. This is the front page, and if it printed entirely, I also included the calendar. And the calendar is the back page. I can just add some dexterity here. So you have basically something that looks like this, and you'll notice highlighted in green are numbers 4.1 all the way down to 12.6, it looks like. All right, those pertain to the section numbers that would be in the textbook. You don't have to have a physical copy of the textbook. If you want, I put the ISBN number on the syllabus as well, but assuming you buy the license for the software, which is what you really need to do, there's an ebook version of this. I'm a little old-fashioned. I like to have a hard copy, which is why I have that. Anyhow, let's start with that. All right. Hopefully you'll have printed this, and if not, you can always do it. You can just look at it, what I have here. All right. I'm gonna sort of erase this, and then I have a little projector here, so I'll just show you the way that this would look online. Okay. I have to adjust my blinds here. You can see my shadow. Let's see. And hopefully this all goes together. All right. So my glasses. And I'll erase this. Okay. Now, assuming you can navigate to the Middlesex County College webpage with no problem. This is what it would look like as soon as you got there, of course. And I'll get my radiator. Word to the wise, if you're going to do anything that is school related, kind of reserve Chrome for this purpose, okay? I'm not saying you couldn't use it for something else, but the software that we are required of this course works best in Chrome. All right. Incidentally, there'll be another handout available that looks like this. This is pertaining to the actual software that is required. Right. This is how you would basically purchase it if you want to do that online. Right. Okay. You need to go through Canvas in order to accomplish that. All right. Don't go to Pearson's website independently of the college and set up an account. I had a student do that once and it caused kind of havoc. All right, let's see. I may make the room a little bit darker to make this more visible. I have those weird adjustable blinds. They're nice, but they don't have a rod. You just sort of, with some kind of precision, pull them down or up, and they change the incline. Anyhow, hopefully that is visible to you. All right. As I was saying, if you could navigate to the web page, the college's web page, you're already ahead of the game. And I go to my MCC and log in through Canvas here. Been away too long, I don't remember my password. Okay. Oh, I have some emails which I'm not going to read now. Alright, let's see. Okay. Either one of these is relevant to you guys. If you're in my IN1 class, as I mentioned, you probably see a tile that looks something like this. It's a little bit hard to see as my projector is not the best, but recognize it for its color. If you're in regular IN, it would be this blue tile, of course. Let me just go here intuitively. Okay, here's a picture of where we are right now. And here's the syllabus. I'm going to leave this photograph of the calendar up, so if you're ever away and you want to know where we ought to be, just look at this calendar. So this is Monday, we're doing an introduction, and section 4.1 will be today's class. On Wednesday, which I'm going to try to keep that consistently, Mondays, Wednesdays for us, is section 4.2. Okay. Anyhow, you can go to this, navigate here, and then hit the preview if you want, or open, save the PDF. Right. That looks decent, right? Anyhow, the way that I made this is that the two most important pages are the front and the back. Right? It isn't that the things in between are unimportant, they're just not as practical information. Right? The calendar tells you where we should be and what the subject is according to the section number at least. And this information will be the requirements of the course. I should put my glasses on again so I can look at it. Okay. As I mentioned, you could be in MAT-114 IN1, or take the page away. Just standard, same thing, different section. MAT-114 IN, right? They're the same class, they're just two different sections of it. This is the name of the textbook, right? Whether you have the ebook or the physical book, and more likely you have the ebook. These are the chapters, of course. Right? If you were in Mathematical Structures 1, we would have covered, the only thing that would have been the same would have been maybe part of 6, right? But there would have been different chapters. Anyhow, here's the ISBN if you would just so happen to want a physical copy for whatever reason. Again, you are primarily responsible for having this software, right? And so, insofar as the calculator is concerned, try to get this type, right? It looks like this, it's blue, right? At least historically it's blue. It is the TI 30X2S, right? Anyhow, you don't need a graphing calculator, you need what is referred to as a scientific calculator. It handles scientific notation. Notice that the screen is not quite as wide, and it's certainly not as expensive. This is a $10 to $20 variety calculator. Okay. All right. As I was saying, the two most important pages of the syllabus are the front and the back. All right. This will be the grading criteria. As you can see from this pie chart, even superficially, all right, most of your grade is coming from your homework assignments. Why? Because we live in Corona world now, all right, and everything is upside down. So you do your work remotely, therefore this is the most important thing, all right? Test would be 25% and the final exam would be 25%, right? Here's the grade scale, and you'll see your running average in Canvas throughout the semester. Okay. Now, to do the homework, again, you would need to utilize this software known as Mymathlab, or sometimes it's just called MyLab. And you would get to that through our tile, all right, and then click on MyLab and Mastering. All right. It should, the very first time, especially if you're not familiar with it, it should walk you through the process of purchasing the software and creating an identification and linking it to our class. If you're in MAT-114 IN, you naturally would want to identify yourself according to what you see in blue here. If you are in MAT-114 IN1, then you want to identify yourself as being in this section, right, with the extra digit here. Okay, if you don't confuse these two, please. You either belong in one class or another. All right, so college students, you know how to differentiate. All right, let me just scroll through this. Again, a lot of this is formality. All right. Here's basically the course expectations. All right. You'll be doing a lot of homework because, again, we're on remote instruction here. All right. I'm going to try to stick with a Monday and a Wednesday schedule so that it's predictable. All right. And again, if you need to know where we are, look at the physical calendar that I drew. All right. And that will tell you what the course section is, the text section is. It will be in green. All right. One way or another, I'm going to be making you 3 tests and 1 final exam. All right. How I'm going to administer that, I'm still kind of debating. All right. Don't worry about that. Worry about your homework. All right. That is the most important thing. All right. The final technically would be on Monday, May 10th. Okay. So read these other policies, all right, please. This is about absences. You need a doctor's note if you're going to be disappearing for a long time. And here are some extra services, which are also useful, including the food bank. All right, notice here there's the food bank information. All right, this is the general course outline. What they 4.1 is today's subject: additive, multiplicative, ciphered systems of numeration. We're going to be covering that in a few minutes. All right, this is what it would be again on the calendar. So do try to print that, please. All right. Let me minimize this and show you a couple of other things. Okay, the student view of this Canvas course is probably a little bit different because I have the whole kit and caboodle and I have to limit a lot of stuff. So what you should see is home immediately, a place for announcements, My Lab and Mastering, pages, and grades at minimum, right? At least when grades are established, right? You want to get in the habit. Let me see if I can zoom in. I'm wondering. Can I do that? Yes, that's cool. You want to get in the habit. Wow, that is really big. Of regularly, at least on Mondays and Wednesdays, all right, checking announcements because that is primarily where I'll be communicating with you. It's not that I won't answer your messages if you send them to me, but if you want to know what's going on, all right, you want to check here. All right, I'm going to make it pretty much consistently. This is the link to the video. This is the link to the materials all through the semester, all right, with the date. All right. The other thing is that if you want to, you could just dig a little bit, right? I'll have the link in announcements anyway, but pages is where I post the handouts that are useful to you, okay? So anything that is pertaining to section 4.1 today, in theory, you could get it from pages if you just click here, right? As I said, the student view would be a little different than my view of it. Let me back off a little bit. You should see right now, meet your professor, because I have a sense of humor here. And this first page really is chapter 4 materials. Right? If you click on this, you'll see a slew of different PDF files that are pertaining to section 4.1. I try to color differentiate. If you click, I'll show you. If you click in here, you'll notice that the first 3 are in blue, then the subsequent ones are red and purple and then green. They're grouped like that according to color because that's when I had originally posted them, right? I wanted to make it obvious to people that, okay, these 3 things are what are pertaining to 4.1. They're related if they're the same color. These 3 things are related to 4.2, right, and so forth. So I'll try to do that consistently. Right. Now, if you go through My Lab and Mastering, all right, again, there'll be a handout. Let me back this off a little bit. With instructions about how to establish an account. In theory, if you were in Mathematical Structures 2, and you've been in Mathematical Structures 1, so it's very likely that you can just keep the same account that you had and just get it to identify with our particular section. Right? So no sense of reinventing the wheel. Anyhow, I'm going to have this page available to you with instructions of how to establish an account one way or another. All right? Just make sure that you're doing it through Canvas, and in particular, use Chrome. All right? Please don't use some other web browser if you can avoid it, because it just may not work the way that it's supposed to. All right? Chrome works best for our purposes. All right. The other thing is, just take it for granted. The older people in your life, when they say, I want you to go on the internet and use a computer, they mean sit at a desk, use a desktop computer or a laptop. You might be able to use the software with an iPad. I never have personally. I'm recording with an iPad, but I don't use it for this purpose. And I certainly wouldn't attempt to do this with a phone, all right? So please sit in front of a legit computer, all right? You don't want to do this with your phone, all right? It's kind of a tiny, inconvenient screen anyway. All right, now let's see. I think that's it insofar as an introduction is concerned. I may end up having to turn my projector on an awful lot. The handout that I will have for you, I made a physical copy of it, and I'll probably do that every day. The handout for today looks like this, right? Again, the materials that you would be able to obtain would be through Pages. We're in Chapter 4. So these 3 PDF files, it just loads. Come on. These 3 PDF files would be the contents of this packet that I have physically printed. It's misbehaving right now because I'm sharing Wi-Fi with other people. That's such a nuisance. Well, thankfully I had the good sense to have this downloaded, so I'll just show you from there. Anyhow, I'm looking at the previews when it's not necessary. All right. If you click on these blue things today and print these out, it would be ideal. Right? They will look like this. Firstly, this table that I drew, and this would be the most useful thing for the entire Chapter 4. A table of different character sets for different number systems. Right? We're going to go through this today. It's a key, more or less. And then the example problems, I've included the answers here because they are a little far out. All right, I'm going to go through each of these with you today. All right, so do try to print those 3 files, and then we'll be on our merry way. Let's see if I can do it. Open that up. There we go. All right. I think rather than keep banging my head against the wall to prove a point. There it goes. Okay. Here's the file I just pointed to. And here's the other one. And here's the third, the actual problems. Right. That one's a bigger file, so it's going to take a while. All right. Enough of that. Let me minimize this. And I'll get rid of that. I'm going to turn my camera off and sort of get to work. Spare the bulb, you know. All right. Fantastic. I'm going to turn our light source here. I don't know if I need artificial light, but if it makes it easier to see, I will use that. Looking at my camera right now to see how well this is and hopefully not casting a shadow, so let me try this without it. It looks a little bit better. All right. I unfortunately am obstructing the natural source of light with my body, which is never a good course of action. All right, let's see. All right. in a notebook, or whatever you're using to write, maybe you do this. Take the first page and just fold over a triangle like so, all right, just to separate out your notes. What we're going to be building toward is, as I mentioned from the calendar, all right, today is section 4.1 on Monday the 25th. Up to the first test would be technically chapter 6 material and a little bit of chapter 10. All right. Chapter 10. Strike that, it's just 4 and 6. Okay, good. All right. My sister is working in the other room, so I don't know if you're hearing her. She has remote work too. Okay. Let's establish this. All right. We have to discuss. I have to go swipe a marker here. Some blues. I wonder if this one writes. No, that's very faint. That's even worse. It's a dud. Let's get it thrown out. We have to discuss today section 4.1. Alright, that's too faint. Basically, there's going to be 4 types of what are called systems of numeration. Systems. Okay. So the first system is known as the additive system. And then we have something called a multiplicative system. Okay. And then the system that is ciphered. And then a system that is called positional. Anyhow, these 3 that you see in red, blue, and green respectively, you don't have to write it like that. These are 4.1. Right? This will be for section 4.2, and we're not going to discuss that today, but it is one of the 4 systems nonetheless. Systems of what? Essentially number systems, right? So you might say systems of numeration. Now to summarize, the types that we will see, right, insofar as additive are concerned, are Egyptian hieroglyphics, I think I'm hearing my sister a little too much. And anyhow, Egyptian Roman hieroglyphics and Roman numerals. Right. An example of a multiplicative system would be traditional Chinese characters. And for ciphered, something called Ionic Greek. What that means is basically ancient Greek, not modern Greek. Okay. Usually what I like to do is give you an overview of the material, a visual aid like this, before I get to the actual examples. So if you don't really follow me, don't feel bad, because we haven't seen any examples yet. All right. Hold on a second.
Get ready. Right.
Well, my apartment is not too well insulated, so hopefully I'm not talking over my sister and vice versa. Anyhow, this is where we are. Insofar as additive systems, again, there's ancient Egyptian hieroglyphics and there's Roman numerals, right? The multiplicative system that we're going to talk about, the example will be traditional Chinese, and the ciphered example will be Ionic Greek. These, again, all pertain to section 4.1. 4.2 are what are called positional or place value systems, right? The type that would be relevant then would be the system that we use, which is really called the Hindu-Arabic system, right? And then also Babylonian and Mayan systems. Okay. All right. Let me turn my projector back on for a moment here. All right. I'll take a moment to boot. And we'll get some formal definitions out of the way. And then we'll continue. I'm going to erase this because I need the space. If you take out this handout, see if this loads now. Nah, you know what, I'm just gonna, it is there, and again, I would encourage you to print that, but let's see if I can just take this from my desktop here. Okay. There's some terminology that would be good to know. I use this diagram throughout the semester to basically, set a good example, basically. You want to collect some vocabulary, all right? Oftentimes, especially in math, there's a symbol that abbreviates the concept, right? And then a little description of the actual formal definition. So you may laugh at this, but the first term, all right, is the word number. Right. I guess we all know what a number is at this point. Gee whiz, imagine if you didn't. All right, a number is a quantity, right? All right, that we express. All right. All right, it answers the question of how many there are of something. Right. Question of how many. My blue is fading out here. But then there's this other phrase, and it's really the reason why I'm mentioning number to distinguish it, right? There's the phrase numeral. Right? What's the difference between a number and a numeral, really? All right? A numeral is the actual symbol. Right? Used to express the quantity. Okay. I thought a pithy way of referring to these two things I had come across in the textbook and I was rather taken with it, and I'll share it with you, is this. To distinguish one from the other. It is said, all right, and this is from page 164 if you want to citate or cite it. We think, right, a number. but we write a numeral. Make that distinction. This is the concept that's abstract. Right? This is an abstract thought. Right? And this is what we actually write, so it's concrete, you know, so far as the actual illustration is concerned. Okay? All right, now as for the definition, and this is the section in the chapter, all right? Systems of numeration. What are systems of numeration? A system of numeration is the set, which you could formally put in fancy braces like this, so you don't really have to, but in discrete math they will do that a lot. Fancy braces, not parentheses. Right? It is the actual set of numerals and the scheme. Right, for combining them. Okay. So this is where we're at, all right? We are discussing systems of numeration, of which there are 4, right? And we're going to cover additive, multiplicative, and ciphered today. Right? Make this distinction. A numeral is the actual drawing, a number is the abstract concept of a quantity. Okay? All right, as I mentioned, you definitely want to print this table, because if you're going to attempt to do the homework, and you really should, right, at some point, this is more or less the key, right? What relates to what, you know? So try to print that, and then we'll go through some examples here. Put this here. All right, let me erase this. Let me turn off the projector again. All right. I hope it's not too dull. I think I may have to open up a new package of markers, because my blue is rather faint today. If it gets any worse, I will do that. I have some extras here. I don't know how sharp they are here. Let me see. Yeah, that's pretty dead. Okay. Normally blue writes the best, but these are terrible right now. Okay. I'm gonna need that a lot. All right. Let's summarize. All right. The Egyptian system of numeration. Basically, the Egyptian hieroglyphics used powers of 10. Right. If you look at this diagram, it looks like this. Right? I'll put it here. And remember, just understand, the Hindu-Arabic system is really the formal name of the system that we are all familiar with. Right? These are the Egyptian characters and what they would be referred to in English. All right, this is a staff or a vertical stroke. This is a heel bone or an arch. This is sort of the profile of a scroll or a coil of rope, you might say. This one makes me laugh because it kind of looks like Mario Brothers to me. You know, a lotus flower. You know, it's like you eat that and you'll have firepower. Actually, the funniest one of all of these is this one, right? Astonished person, right? An astonished person represents this particular power of 10. This would be 10 to the 6th power, right? I guess that, you know, if you think about it, like, it's such a large number that it's shocking. Hence, the astonished person would be appropriate to describe it. Anyhow, this is 10 to the 0, 10 to the 1st, 10 to the 2nd, 10 to the 3rd, 10 to the 4th, 10 to the 5th, and 10 to the 6th, right? The number of zeros is also the exponent, hence these are powers of 10, right? And we would opt for these symbols when we're trying to explain or illustrate these quantities. Anyhow, one thing that is important to note, right? This system that is an additive system, right? The Egyptian system is an example of an additive system. Right, is repetitive, right, which means that if you wanted to explain a quantity in between 1 and 10, since there are no other characters, in between 1 and 10, you know, how do you explain 9? In this very old system, they would just simply keep drawing the same stroke, right? The same staff symbol, right? So there is a slightly more complicated way of doing this when we get to Babylonian, all right? But you really would just go, if you wanted to explain 9, you would just go, okay, it's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's repetitive. Right? You just keep repeating the same symbol. And in theory, you're adding 1 to 1. That is 1 plus 1 plus 1 plus 1 plus 1 and so forth. Okay? Kind of neat. Rather than torture myself, I'll take out this packaging. I'm going to leave this here so I can point to it. One other thing that will distinguish it from Roman, you'll see later, is that the order is not important. Right. You may see two different orders of symbols and they would represent the same quantity. Okay. The Egyptian symbol is system is mostly adding. All right, there's really not much to it beyond that. That is how sophisticated the math was, if you think about it, 5,000 years ago. All right, all right, not too complicated. Also, there is no symbol for 0. Which I think I should physically write out. Now, the system that we use now, the Hindu-Arabic numeral system, system of numeration, right, does incorporate the 0, right? And that is why it is a superior system, because in order to do more sophisticated math, all right, we need this symbol, all right? All right, so if you don't have that, you're already limiting yourself. Because I'm running out of space, right? The Egyptians were familiar with fractions in respect of the of a reciprocal, right? this symbol, which looks kind of like a 0, but it isn't. So I'm kind of trying to make it a little bit more oblong, exaggerating it this way to make it oval shaped, means reciprocal. So for example, you saw, I don't know if my cup is in the way here, the symbol and then 3 strokes underneath it, like so. It would mean form the reciprocal of 3, right? What's the reciprocal of 3? 1/3. Yeah. Something like that. If you had seen, for example, here's another one, I'm just running out of space here. 1 and then the heel shape, right? This is 1 plus 10, right, which is really 11. This is the reciprocal, therefore, of 11. So this would be 1/11. Okay. Let me go through Roman, just for the sake of contrast, and then we'll do our first examples. Let's talk about the Roman numeral system. All right. This is another example of an additive system, which means it's going to be repetitive. All right. The difference, though, between the ancient Egyptian hieroglyphics and the Roman numeral system, aside from they were concurrent. You know, do beware. At least up to the time of the early Roman Empire. Order is important in the case of the Roman system. This is distinction. And there are the more specific rules. The characters you might be familiar with. If you had gone to Catholic school, this is one of those things that they, for the sake of tradition, they would teach you. Right? The characters are capital letters like I and V and X and L and C and D and M. And basically what they would translate to, again, you have this on this piece of paper here, right? The Roman numeral systems and what they would translate to our system, Hindu-Arabic system. I is intuitively 1. V, I would guess, is something like the outline of your hand. And a V on top of a V is an X, right? So that's 10, right? I'm extrapolating, I don't know that for sure, but that is a good way to think of it anyhow. This is really 1, 5, 10, 50, 100, 500, and 1,000. If you ever watch the credits at the end of a movie, a lot of times you will see, Roman numerals. It's just for the sake of tradition. They had been used for a very long time, right? The problem with them is that, again, they had some distinction here. There is no 0. Like the Egyptian system, there is no 0, and therefore it is damned. It is doomed as a system for more complex math. right? We need a 0, and then we don't have it. If you don't have a symbol for 0, all right, that makes things more complicated. Aside from having to write things redundantly, all right, that is also complicated. All right. Now here are some ground rules to remind you. This is read from left to right. You'll see in other systems that that isn't necessarily the case. All right. There are no more than 3 characters that are the same in a row. Right. So, whereas in the Egyptian system, and again, when we were expressing the concept of 9, you could just keep writing 9 single strokes, right, to get up to 9, right, if you really wanted to. In the Roman system, you can't get away with that. There are some limitations. It is repetitive, but not quite as repetitive. So you're only allowed to have a maximum of 3 in a row that are the same. Okay. Just because I'm a little short on space here. This is called an additive system. It is an example of an additive system, but this is something that can perform adding or subtracting. Right? In the case of the Egyptian system, there really is no formal subtraction. It's just neglect to write an extra symbol. You know, how do you, if 9 is 9, vertical strokes, then 8 is just 8 vertical strokes. You just don't write, as many. Right? In the case of the Roman system, there's a system for it, right, which I'm going to go into now. And it has to be, this is why the order is in fact important, right? Order decides whether you're adding or subtracting. Let me give you an example. I have to erase a little bit. If you were to see I and then a V immediately after it, this is a situation where you would subtract, right? You would subtract 1 and 4, 1 and 5 rather. I'm neglecting to write the minus here because it's really not, if you are familiar with integers, all right, you might be a little vexed by the order of that, right? Being a positive outcome rather than a negative outcome. Anyhow, not to belabor the point, all right? Basically, you're subtracting, all right? When you have the symbol on the left being less than the symbol on the right, all right, that causes you to subtract, all right, and this equals 4 for that reason. If, on the other hand, you have this, use green if it isn't too faint. Is that visible? It's okay, all right. V and then an I, right? This is a situation where you would add, right? And the reason for that is that the thing on the left is greater than the thing on the right, the symbol, I shouldn't say the thing, the Roman numeral, right? When you have this situation, V is a larger quantity, all right? It's 5, right? And this is a 1, right? 5 is greater than 1, so therefore you're going to add. And then you end up with 6. Okay? In this case, just to reiterate, this is 1 is less than 4, right? Pardon me, I'm jumping the gun here. 1 is less than 5. So therefore you're going to subtract. Okay, the order definitely matters when you're talking about the Roman numeral system. Okay. Sort of save this for your own sake when you're doing those assignments. Left is less than right, then you subtract. Right. When the left is greater than the right, as in this instance, then you add. And you kind of read these in pairs always. Make a habit of doing that. Compare 2 at a time as you're reading it. One other little tidbit here. I'm running out of space. Put a little bullet point here, forgive me, right? When you see a bar above a numeral, it means multiply by 1,000. Right? There is a symbol for 1,000, M, but how would you explain, something beyond, that limitation, right? Like if you wanted to explain 10,000, right? You would need to take 1,000 and then multiply it by 1,000, right? Or by 10, rather. Right, so if you saw something like this, I need a little bit of space. Let me write this here. C and then a D, right? Here you have 100, and then you have D is 500, right? What's their relationship in respect of reading this left to right? This is less than this. Therefore, what you would have to do is subtract, which means that this is really 100 minus, subtracted from 500, which means 400, right? If on the other hand, you saw this, CD with a line over the 2 of them, right? That would mean multiply that quantity times 1,000. So if this is really 400, it's 400 times 1,000, right? How many zeros do you have, right? Just to, as a mental math skill. 1, 2, 3, 4, 5. Your answer will have 5 zeros. 1, 2, 3, comma, 2, 4. All right. So 400,000 is what that would equal. Right? There's no letter to represent that by itself, or even 100,000. So you'd kind of have no choice. You have to do multiplication. You have to, it's funny, again, not to belabor the point. How often do we, in our real lives, interact with very large quantities, right? I played the lottery a couple of days ago because everybody was, what was it? The Mega Millions, right? It was like $1 billion or something like that. And I didn't win. Anyhow, it's so beyond what you actually need to live, right? It's almost difficult to grasp that. So these old systems were, quite limited, right, in their ability to illustrate a very large quantity because it wasn't practical, right? That's why, again, this makes me laugh. The Egyptian system, you have a little character that is described, at least in English, as the astonished person to represent 1,000,000. So you just could not fathom that, That's a lot of grain, right? The ancestors would be very impressed. All right. Let's do some examples. Yeah. Okay, if you have this printed again, take a look at these 4 examples. I stole these from the textbook. The answers are included because I don't know if you're watching this or not, and I wanted you to make sure that you know what the answers were. So let me turn my projector back on, spare myself from maybe having to draw this over and over again. No, maybe not. Let's do a couple of Egyptian hieroglyphic and Roman numeral translations, if you will. This is example 1, swiped from the textbook. Again, this is on this sheet, if you have that printed, and we'll go through it. Basically, if you're going to write Egyptian hieroglyphics, ancient Egyptian, in the standard Hindu Arabic system, right? What we know. Right? If you had characters that look like this, and I have to unfortunately draw this, awkward as it is. What you're going to do essentially is, being it isn't too complicated a system, you're going to go right for your key, all right, and see what each of these things are, right? Maybe write them underneath them just to keep account of it, and just add them, right? It is an additive system, right? The pointing finger, right, is 10,000. The profile of a scroll is 100, right? The heel bone is 10, and the staff or vertical stroke is 1. So what that means is that you essentially have 3 pointing fingers. It's like an old dude, you know, kind of giving you the finger here. That's 10,000 to represent that particular one, and then another 10,000 to represent that particular symbol, and then another 10,000. And then profile of a scroll is 100. That's 100, and then 100, and then 100, and then one heel bone is 10, and then all of these are, you know, 1 plus 1 plus 1 plus 1. I'm cheating on that last one just because I'm running out of board space here. But these are what the individual symbols would be. Now we would just simply add them all. This is again an additive system. 3 10,000s is naturally 30,000. All right, 300s is naturally 300. 10 is 10, and 4 1s is a 4. Right? So again, you could just, don't ever feel bad if you write something that seems like, oh duh, you know, why did I bother writing it? You are illustrating your thoughts, right? Whatever anybody ever told you in your life that I have to do one thing in your head. No, you don't, right? Especially if you're a teacher, and this is what presumably what field you're interested in, all right? You want to show people the inside of your head, and the only way that you can do that, aside from talking at them, is to draw. So do write what you're thinking, all right? 30,314 is what you would get as the standard Hindu Arabic numeral system equivalent. All right. Okay. Now let's say that you wanted to go the other way. Starting with the Indo-Arabic system and convert to Egyptian hieroglyphics, and you have this quantity, let's see, 1,203,462. Don't say the word "and," even though I know in colloquial English we would tend to do that. "And" implies that there's a decimal point and there isn't one. Right? You won't really have to worry about that, all right? But it's good etiquette not to say "and" unless it's appropriate. All right, so 1,203,462 is the quantity. Hopefully this isn't too much of a nuisance here. This is my window. All right. Now, when you're doing this, you want to write it as a sum. And if necessary, keep breaking into powers of 10. Remember, in the Egyptian system, there are no symbols in between 1, 10, 100, 1,000, 10,000, and so forth. All right, you would have to just simply add or not write, something if you wanted to, get something in between. Anyhow, so I'm going to sort of break this up into place values. And so, firstly, it's 1 million. And maybe I'll be a good guy and I'll isolate this. Plus, next place is 200,000. And then there's nothing in the 10,000s place, so I'm just going to use 3,000. And just because I wasn't too strategic here, I'm going to write this underneath it. 400. And then 60. And then lastly 2. All right, we're going to keep breaking this down, of course, but this is what you would start with potentially. All right, 1 million plus 200,000 plus 3,000 plus 400 plus 60 plus 2. This is a power of 10, right? And there's a symbol for that pretty much right off the bat, right? If again you look at the diagram of Egyptian symbols here, hieroglyphics, 1 million is the astonished person. So if you wanted to, you could just immediately, represent that, and I'll put it here perhaps. Here's a little heavy-set fella, kind of going, my God, such a quantity, 1 million. Okay. This is not quite a power of 10, it's 200. So we're going to try to keep breaking that down until you get into powers of 10. Think of this as being a sum unto itself. So what is 200,000 really? It's 100,000 plus 100,000. Right? And there is again an Egyptian symbol for 100,000, which is the tadpole. Looks like a Jesus fish, sort of, right? So you would have tadpole and then a second tadpole. Okay. 300,000 again, break it down into just powers of 10. So this is 3,000. What is that really? It's 1,000 plus 1,000 plus 1,000. And again, you gravitate over to your table. what is the character that we have established for 1,000? The lotus flower, right? Fire flower, right? If you will. I hope I'm doing it justice, right? It's sort of a crescent moon. Drawing 3 of them, this is 3,000s. All right, sort of a downward pointing arrow coming out of each one, and then a pot. That's how I think of it anyway. 400, all right? That is 100 plus 100 plus 100 plus 100 plus 100. All right, and that is the profile of the scroll, right? So, or each 100. And then 60 is what? 10 plus 10 plus 10 plus 10 plus 10 plus 10. And that is the heel. Looks like to me an impression of a person's foot in the sand, just the heel portion of it. Heel, 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 heel. Right. Right. And then lastly, there's 2, which is really just, 1 plus 1. Right. So, and that is kind of almost the same symbol. Intuitively, a vertical stroke and then a second vertical stroke. Right. So all said and done, right, what should you write? I'll put it down here, hopefully it's visible. Astonished man, person, dude, human, all right? And some fish, sort of the tadpoles, right? Crescents. Scrolls. Heels. And 2 vertical strokes, right, in sequence. If I was, again, a little bit more strategic, I would have saved myself some more board space, but I'm going to encapsulate this to sort of draw attention to it, right? 1,200,000, 3,000, plus 400 plus 60 plus 2, right? No subtraction, right? Let's do some Roman translations here.
Okay, I would need him present on the phone call to help with that, if that's okay. So have him call us, or if you want to call together, that's fine too. I just need permission to do it. Is he at home right now?
Okay, we're going to now translate or write Roman numerals in the standard Hindu-Arabic system. And we'll start with this sequence of characters. M, hope that's visible. D, C, C, L, X, X, V, I. Right? This is another example of an additive system, of course. And as long as we are reading from left to right, right, you should get in the habit of comparing these 2 at a time. Right, to decide whether you're really adding or subtracting. Right. Remember again, if the left is greater than the right, then you add. Whereas if you have the left is less than the right, then you're going to subtract.
I know, I have to set temporary password to a phone number. Is it okay if I set
The symbol that is M is 1,000, and the symbol that is D is 500.
Okay,
So
you're gonna
1,000 is far greater than a 500, so we're just going to add these two.
write down that number and share it with her as a Google
All
phone.
right, which makes this 1,500 right off the bat.
Okay, I'm sending that.
Okay. Then you see C and then another C. They're equal to each other. So that's 200, because it's 100 plus 100. And then we have L and X. Right? L is 50, and this is 10, and again this is the same relationship. So you would add in theory 60, and then you have another X, which means you're going to add another 10, which makes that 70. And then you have a 5 and a 1. Again, you get it's greater, so you're going to add, and that gives you a 6. Right. So you have 1,500, 200, 70, and 6. 1,500 and 200 is 1,700. 1,700 plus 70 is 1,770. And 1,770 plus 6 is 1,776. You might, especially again, if you had gone to Catholic school, all right, this is the kind of thing that they teach you just for the sake of tradition. And you might just intuitively know how to do this already, but if you have no idea, here's a system that works, all right? All right, read left to right, all right, compare two at a time, all right? Here's going the other way, the Hindu-Arabic system. Back toward Roman numerals. Oh no, I'm sorry, this is the same thing still. Roman numerals still. And we're going to convert to Hindu-Arabic again. Okay. This is going to incorporate subtraction. So here's the original quantity. C M L X I V. Wish my blue was running out of time. Okay. Reading left to right, we're going to compare two at a time here, and then we'll decide whether we're going to add or subtract, basically. So, this is 100, and this is 1,000. Right? So, this is the relationship, right? The thing on the left is less than the thing on the right, therefore we're going to subtract. What's 1,000 without writing a minus symbol here, because I don't want to get into the issue of a negative. What's 1,000 minus 100? 900, right? Then you have L, 50, and you have X is 10, and this is the relationship. So 50 is, the thing on the left is greater than the thing on the right. We're just going to add them as we normally would. Right, so this is 60.
Hello, can you hear me?
And then we have these two. 1 and 5, this is the relationship. 1 is less than 5, so we're going to subtract again. So therefore this is 4. Alright, so if you combine all of these, what do you end up with? 964.
And this is Israel, right? Okay,
I'm thinking as I did that last one, this is correct, and the answer to the last problem was correct as well, but to set a better example for you, humor me for a moment. This is exactly as I would do this particular problem. This was example 4, right? Just to make sure I don't misinform you here. Look at this again for a moment. I kind of skipped it. I really didn't take my own advice, and that bothers me. All right. I did do this. All right. This is 1,000, and this is 500, and that's the relationship. So therefore, it's 1,500. 2 at a time is they're equal to each other, so you're just going to add them as 200. When I got here, this is where I kind of digressed from what I really, again, to set a better example, what I should really do. If I'm doing 2 at a time strictly, again, this is 50 and this is 10, and yes, that's a relationship, so this is 60. But then when I do the next one here, I really should read these 2 at the same time, technically, right? So that's 10 and then 5, right? This is the relationship still, 10 is greater than 5. So you're going to add them, which means that this is 15. You're going to get the same answer one way or another, but I think this is me being more consistent. And then you just have this 1 left over here. 1,500 and 200 is 1,700 again. 17 plus 60 is 1,760. 1,760 plus 15 is 1,775, and 1,775 plus 1 is again 1,776. You get the same answer either way, but again, this is being more consistent with the spiel that I gave you, which is that you compare 2 at a time. Okay. We do 2 more examples of Roman numerals, but we'll be going the other way now. Starting from a Hindu-Arabic numeral, or numerals, and converting to Roman numerals. If you had the quantity 439, this is in standard Hindu-Arabic numerals. Just make it a hint darker, please. All right. Let's break this into a sum. Right. According to place values would be the most intuitive thing, right? This is 400 plus 30 plus 9, right? Unless you have a symbol for what you see broken up into a sum of place values, you're either going to have to add or you're going to have to subtract, right? Now, again, we have some sort of rules of etiquette that we have to conform to, right? No more than 3 symbols in a row. So you might intuitively go, all right, well, I'm going to just add, right? So I'm going to look at my Roman numerals and go, well, I have a symbol for 500, which is too much. And then I have a symbol for 100, which is too short. But if I intuitively add, then it would be like the Egyptian hieroglyphic system, which would be 100 plus 100 plus 100 plus 100. If we were talking Egyptian hieroglyphics, that would be totally fine. But since this is the Roman system and we have, again, this sort of etiquette, no more than 3 of the same in a row, all right, I can't get away with adding here. All right? What I have to do, all right, rather than attempt to do this, 100 plus 100 plus 100, right? rather than do that, right, I have to subtract.
But you were wondering,
Right.
if you
So what I would subtract is intuitively 500 minus 100. Right? In which case you would have the symbol for 500. I hope that that glare is not really making this harder to see. The symbol for 500. Is that a little bit easier? Slightly. I wish my body would block it while I'm writing it. The symbol for 500 is D, right? And the symbol for 100 is C. But if you have it in this orientation, it would add rather than what we need it to do, which is to subtract. So what we have to do is switch the position of them like that. It would be CD as opposed to DC. Right? 30 is, there's no symbol for 30 again. If you look at the table, we have a symbol for 50, and we have it, that's too much. And then we have a symbol for 10, which is too short, but we could add intuitively. So, as long as it's no more than 3 in a row, it's fine to just go, all right, it would be 10 plus 10 plus 10, right? Which means what? It means X, X, and X. Right? Then we have the situation again with 9. Right? We have a symbol for 10 and we have a symbol for 5. 10 is too much, 5 is too short, but if we were going to try to add, all right, it would be 5 plus 1 plus 1 plus 1 plus 1, right, to make 9. And this is not Egyptian, so we can't get away with doing that, all right? So what we're going to have to do, rather than that, is subtract. So we're going to take the thing that is overshooting it, namely 10, and we're going to subtract 1. Right? But even though we would use X and we would use I, right, the order matters. Right? If we want this to do subtraction, which we need it to, the I would have to be in the front and the X would have to be after it. Which means, all said and done, this would be your answer here. CDXXXIX. It's just very sloppily written here. Okay. One more of these and then we'll shift gears and talk about multiplicative systems. Okay. How are we on time? An hour and 23 minutes? Okay. Again, we're going to start with the Hindu-Arabic system of numeration figure. So if we had 12,345, and we're going to convert this to Roman numerals. Right? Right, let's start with, again, let's try to break it into a sum, right, according to place values, if we can help it. We are beyond 1,000 in this case. Right? There may be more than one way to do it, but I'm trying to not keep myself out of trouble here. In this case, I'm going to put a little thought cloud here. we are beyond 1,000, right? All right, we may have to multiply. Which means we're going to use bar notation. Somewhat ironic. Bar notation in the modern sense is used to indicate a repeating decimal, right? All right, anyhow, it might be intuitive to go, okay, it's 1/10,000 and then it's 2,000. I'll try to do it the other way after I do it the way that I really should. All right, and we'll see if I can get away with it. If I break this up into 12,000, just because we have a system that doesn't have any character beyond M, right, for 1,000, and then 300, and then 40, and then 5, right? This, in this style of writing it, would be intuitively, well, if it's 12,000, what does that mean? It means 12 times 1,000. Right. How do I explain the quantity of 12? Right. 12 would be 10 and then 2 i's, right? But if I want it to be 10, if I want it to be 12,000 rather than just 12, then what I would do is have it as XII with a line over that sequence, right, to explain times 1,000. Now the other ones are mostly intuitive. When you have 300, right, you can get away with just simply adding, right, because it's really 100 and 100 and 100 added, so that would be an additional C, C, and C. 40, you're going to get in trouble, right? There's no symbol for 40, but what we do have is a symbol for 50 minus 10, right? So we have an L and an X that have to be combined somehow. If we want it to be subtraction to accomplish that quantity, then the X would have to be in front and the L would have to be afterwards. So we have X and then L, and then 5 is just B. And this, all taken into consideration, is how you would write it. This is an example using bar notation. Again, when you're beyond 1,000, all right, remember you're going to have to probably multiply using bar notation. So a good rule of thumb, make it easy on yourself. Right.
My coworker's trying to help me. She's just on the phone with another member. She has authority.
I'm trying to think.
Yes.
There's no symbol for 1,000. No, there's no 10,000. All right, this is the only way you could do this.
Okay, it looks like she's typing to me.
Since there is no symbol for 10,000, you're pretty much stuck doing that times 12 times 1,000. Okay. All right. Let me get a sip of water here. All right, we're going to shift gears now and talk about the multiplicative system. The example that we have, the principal example we have is of a multiplicative system is traditional Chinese. Right. Okay. as far as our systems are concerned, we have additive, right, multiplicative, right, and eventually we're going to get deciphered. Again, additive systems are Egyptian that we talked about, and Roman numerals. All right, what we're going to do now, as our chief example of a multiplicative system, is traditional Chinese characters. And I think I'm getting fed up with this blue, so I'm going to go upstairs and steal, open up a package of a new one. Right. Anyhow, this is the objective right now. Pardon me one moment. Blue, please. I'll leave that there. All right. Is that any better? I don't know. Writing on top of what is already written is not necessarily constructive, right? All right. It's a little darker. Free up some space here. All right. What do we have to pay attention to here? Let's see. Traditional Chinese, a multiplicative system, right? Is written vertically. Meaning in this orientation. Usually in pairs, but not exclusively. But in a situation like so, it's the new one. Yes. And that's the dud. Yes, that's the dud. Okay. The top pair of characters is usually something that represents the quantity of 1 to 9. All right. The bottom is a power of 10 used to multiply. Okay. And there is, very importantly, right, there is a symbol for 0. Alright, now again, the handout that you definitely want to print out, unless you are familiar with traditional Chinese characters, alright, is this page again down here. Alright. Notice something interesting. There is the intuitive representation of the quantity 1, 2, and 3, right? If it, look, that's one thing that is consistently true through all of virtually all of these systems. The Ionic Greek is an example that is counter to that point. But what represents 1, right? A vertical stroke, right? What represents 1? A vertical stroke that just looks is an eye officially, meaning it's, you know, it has a little fancy top and bottom to it. But even still, in the traditional Chinese characters, it's the same symbol, all right? It's just oriented horizontally this way, all right, rather than vertically, all right? When we get to Mayan, you'll see that that is true again as well. I can't help but sense that probably because our concept of numbers originates from our hands, all right? That is the symbol for 1, right? Intuitively to humans, right? Whether you're pointing this way or pointing that way, right? That's 1, all right? And it goes up to 3 like that. That's just 1, 2 fingers, 3 fingers, right? Then beyond that, I'm not certain, right? But this is the symbol for 4, 5, 6, up to and including 9, and then the powers of 10. 10 itself, 100, and 1,000 we have, right? At least that's what we are given here, all right? And here is the symbol for 0, all right? Which to me, and I'm not sure what the origin of it is, all right, it looks a lot like a face, a person's face. When I draw it myself, that is really what I convince myself to help me remember how to do it, right? Sort of draw a face. All right. A couple of other official points here. Let me see if I could squeak it in down here. What we think of as the ones place, this textbook uses the phrase units digit. Right? It is never multiplied. And then there's another some special cases here, right? I'm running out of space, so I'm going to erase a little bit. This. For numbers between, say, 11 and 19. Right. Just write the symbol for 10. And then the extra symbol. Either for 1 or for 9 or for 2 or what have you. And there's one other case as well. There's another special case. I definitely need to erase this because I need the space. I'll put this here. When you're concerned with having zeros, try to reserve this information because we need that model sort of. There are situations we have zeros between non-zeros, and when you have zeros on the end. no matter how many zeros that you have in between non-zeros, one symbol
We should be able to, let me just confirm if we need any signature from her.
is sufficient.
Yeah. Yeah, of course.
So even if you had 2 zeros in between non-zeros, you're just going to use 0 once.
Right. Of course.
And 0 does not need a multiplier.
Thanks for the warning. So do you have the member's phone number by any chance? I could look her up.
Right, as for zeros at the end, you don't have to write it at all. If a 0 occurs at the end, you just neglect to write it.
Alright, I tried looking up her name. Do you mind giving me the number again?
Okay, that's an overview of what we'll be doing with this multiplicative system. I'll give you some examples. Again, in the packet, we had gone through the first 6 examples, and I will do the 7th one. And we'll work on this now. And I should probably keep this handy. Let me erase this. It is noon from the sound of the church bell. So our example will be, this is technically example 7. To write what is given in the standard Hindu Arabic system as traditional Chinese. Okay. So let us say that this is the figure that we're working with. 538.
Yeah, we can do that. Yeah, I love that. Come over here if you don't mind, but I would love to. Okay, alright, I'm gonna be done at 5, so, help me with that.
As before, right, try to break into add-ins would be the technical term, place values. Just remember that you have to do it vertically. Sorry, that's kind of sloppy. Set a good example. Vertical, like so. So what I do, sort of for my own sake, is I like to draw these sort of calipers. Right? You don't have to do this, but it kind of helps me, like a little scaffolding here. Right? I'm going to express the quantity 538 as its 3 place values broken up, but stacked vertically rather than written horizontally as I had before. So we'll start with 500, right, 30, and 8. Right. Remember the Chinese characters that we have to work with here. Right, we have unique symbols, as we do in the Hindu Arabic system, between 0 and 9. Right, and then we have powers of 10. This is a superior system to the Roman numerals already for that reason. Right, it's not too complicated a system. It might be a little, it might be alien to you know, an American person perhaps, all right? But it works in a very similar way, right? We have those unique characters, right? And then we have the powers of 10, right? So we're not limited or as limited, right? I'm going to take this and break it up even further still into a top figure, a number that is expressed between 1 and 9, and then a multiplier, right? So this is going to be 5 times something, right?
Yes, you got it. So would you like my extension? I'm sorry. Yes.
In order to accomplish this quantity, 500, what would I have to multiply 5 by? I would have to multiply by 100. So now I'm going to try to emulate the traditional Chinese character for 5 on top, and then underneath the traditional Chinese character for the power of 10, that is 100. Right? And I'll keep it in a consistent color sequence here. Humor me, because I'm not too good at this. Right? But the more you do it, the better you get at it. You would go to naturally where you see 5, right, and try to emulate this character. Right. What's a little difficult for me is that I'm used to using pencils and pens. All right. I think traditionally this was probably done with a brush stroke, an actual paintbrush, which is why it's so elegant, really. Right. And that makes it more like calligraphy than it does a standard ballpoint pen. I could kind of get away with it with a chisel tip dry erase marker, but we'll see. All right. I don't want to not do it justice. So I'm going to kind of look at this a little bit more closely and then get out of the way of the camera. I did actually try to learn calligraphy at one point. But my calligraphy definitely needs some improvement, you know. Anyhow, that is supposed to be the character for 5, you know, just drawn by me, so not so hot. Now, immediately underneath that, the character for the power of 10, that would be 100. So this is sort of like an amped up version of 10, all right? If you can think of 10, the analogy I would use is that this is something like a plus or a cross symbol, right? But with an extra stroke above it, right? It's very similar, right? That's 1,000, actually, I'm sorry. 100 is more, I'm not trying to be disrespectful when I say this, but it kind of looks like a helicopter in profile, right? There's a propeller and then a box underneath it. All right, so 5 times 100. You already have that much of the original quantity. All right, now 30, similar process. You're going to do this in pairs. Go ahead. Do you hear me? I'm sorry. Do you hear me when I'm babbling here? No? Okay. That's my sister. Anyhow, 30 is, again, think about it as the non-zero digit, right? And then times a power of 10. So if you can think of this as being 3 times something, all right? What would that be? All right. The intuitive horizontal incarnation of 3. Right, 3 strokes horizontally rather than 3 strokes vertically, right? The Roman numeral system would be 3 vertical strokes, right? Right, or in theory, the Egyptian hieroglyphic would be 3 vertical strokes. Right, this is just doing it horizontally. right? A little bit more stylized. Again, the implement of choice, right, affects how it looks, right? If I had a nice paintbrush, I'm hoping I would do a better job of it than when I am with a chisel tip marker. Anyhow, this I'm trying to stylize here. So 3, and then now we're going to use the multiplier of 10, which is, to me, it looks more like a cross shape. Again, not to be disrespectful of it. I'm just sort of feeling around here for an analogy. Oh, I have a scratch. Okay. So 3 times 10 is your 30 portion of this original quantity. This is enjoyable, I feel. All right, this is the units ones place essentially, right? So there is no needing to multiply by 1. All right, you just write what the figure is. So we're going to go directly to the traditional Chinese character for 8, all right, which looks like this. To me, it's kind of a mustache. All right. I'm only saying that again to sort of help you, you know, when you're trying to decide if you've never done it before, and this is only my second semester doing this, think about a way to emulate. Okay. All right. This vertical sequence, I really, you know what I really should look up actually, it's not written anywhere in your book, but how you would actually pronounce this. All right. This is the quantity 538 in Hindu Arabic, our traditional system, and this is the traditional Chinese vertical incarnation of this. Okay, my computer died here, that's not cool. All right. Let's see. All right. Let's do a more complicated example. That involve the special cases. Yeah, we're close to 2 hours now. Okay. Let's say that we started with the Indo-Arabic numerals 7080. This is one of those special cases where you have a 0 in between non-zeros and simultaneously a 0 on the end. So we're going to compensate for that. Okay. Again, I would start out with sort of drawing these little sandwiches. A caliper, all right? And then break this up into nice round numbers. So you have 7,000. There's no non-zero digit here, so I'm just going to sort of leave that out, right? And then there's an 8 here, so this is really 80. And then there is a 0 on the end. Right. Now, as we were saying before, right, between, right, write 0, the equivalent. and once is sufficient. Even if there was 2 digits in between here, right? 2 zeros in between, you would just write it once, right? On the end, don't write it. Hopefully that is visible. I don't know how visible it is. Green is always a problematic marker. All right. Anyhow, I'm going to proceed to break up these now. This is going to be 7 times something, right? 7 times 1,000, right? So we need to illustrate the character for 7, and then we need to illustrate the character for 1,000 to the power of 10. 7 you see here is, to me, it is similar to tau, the Greek character, at least the lowercase. Here, if you look up here in Ionic Greek, that is a, I want to say, I don't know if that's lowercase or not. It is sort of a script T shape. So 7 people in China are probably like, wow, you have terrible handwriting. I need to work on that too. Okay, I do. And then there's the symbol for 1,000, which again is kind of an amped up version of a 10, right? It's a cross shape with an extra piece of flair here, an extra stroke. Now, as we said before, if we have the 0 and we do in this case between, right, we are going to write the symbol for 0, right? The symbol for 0 is the most involved, right? So this is going to be the equivalent of 0 here. So I should have just did that to begin with, right? And to me, again, just trying to form an analogy, it looks, it's pretty actually, this symbol. It looks to me like a human face, right? There's a man wearing a hat, if you will, right? And a little bit of face paint, if you will. So if that helps, right, to think of it that way, when you're trying to learn how to draw this, do that, all right? Convince yourself, all right? Here's a hat. And the size of the person's head. And a line this way and 2 eyes. Sort of a nose. And then a mouth. A smiling 0, if you will. All right. And then we have to do 8, 80 rather. 80, again, is going to naturally be 8 times something. Right. Times what though? Right. Would have to be times 10. Right. Which means the symbols for the symbol for 8, which to me is something like a mustache just to get you started. And then 10 is the cross shape. Should probably, when you're learning this, use an actual brush and not markers. Being hailed somewhere. Okay, now there's the last situation here. We have this 0. You intuitively would want to put a 0 here as well, but don't do it. Don't write it when it's on the end. All right, in other words, do not duplicate the symbol for 0 down here. It's unnecessary. What is written vertically from here to here is sufficient. Right? 7 times 10, a 0 in between. Even if there was an extra 0 in here, you would just have to write it once. And then 8 times 10, right, which is 7,080. Okay.
Yes, hi, how are you?
Okay. All right, now let's get to the last thing. Additive System. Which is again Ionic Greek is the example that we have. There are other systems just like this. I'm surely there's other systems besides traditional Chinese for multiplicative, but it is a good example of that. And that is really all that you're responsible for. All right. Here are some fun facts about Ionic Greek, which is essentially, ancient Greek, not modern Greek. Just like ancient Egyptian hieroglyphics are not modern Egyptian. This is firstly an example of a ciphered system. Now, what distinguishes a ciphered system from any other is that it includes numerals, let's see, I'm trying to sort of phrase this concisely. For a base, all right, and multiples of the base. So let's just say hypothetically, if you have a base like 10, right? In other systems we have seen, we just had powers of 10, right? So we had 10, and then we had 100, and then we had 1,000, right? 10 to the first, 10 to the second, 10 to the third. This ciphered system will include multiples of that base. So for example, not just 10, but 20 and 30 and 40, right? And although that makes it maybe a little bit easier to translate immediately, there's a lot of memorization that would really be involved. Right? This has a lot of characters. Which doesn't make it, necessarily intuitive. Right? As a matter of fact, it digresses from what I would argue is intuitive. Right? Remember, even Egyptian, all right, had the intuitive vertical stroke as in 1. Right? And Roman numerals are really just a derivative of a finger 1 as well. Right? And traditional Chinese has it's just a horizontal stroke alternatively. All right? That does the Ionic Greek alphabet is 24 Greek characters and then 3 obsolete extra ones, all right? And they look nothing like anything but an ordinary letter, all right? As a matter of fact, to distinguish what would be a number from just a regular word, right? They would have to use something that looks kind of like an apostrophe, all right? That isn't something that you're going to see in this textbook, all right? but that is traditionally how it would be distinguished. To differentiate a word from a number. All right. Anyhow, there's a lot of unique characters, which means there would be a lot to memorize. Once a person has that memorized, though, right, it might be a little bit easier to use, right, than any of the other systems. It doesn't really involve anything more than adding, really. Okay. Let's see. There is one other little caveat here. Let me just make sure I cover that. There's 27 unique characters total. That's 24 regular and then 3 obsolete. And then in this textbook, if you see an iota, which is a letter that looks like this, kind of like a stylized I, or a backwards J, if you will, right? In superscript, it means multiply by 1,000. Right, so for example, if you saw something like this, theta, and then in superscript in front of it, iota, like that, it's saying that this is not a letter, this represents a quantity. So this is really, theta is the symbol for 9, and iota means times 1,000. So this would equal 9,000. Right? That's to basically get you beyond the limitations of just 27 characters. Right, as you can see from this chart here, right, there are the unique numbers up 1 through 9, which is convenient. But then there's unique characters for multiples of 10. So there's a 10, there's actually a 20, a 30, a 40, a 50, 60, 70, 80, all the way up to 100. And then beyond that, 100, 200, 300, 400. All right? But it ceases to exist at the point of 1,000, so that's where the iota comes from. Right? Again, iota, and these are lowercase, all of these. Where's iota? I'm looking at it backwards. Oh, it's down here. See, it's sort of a stylized I. But it's in if it's in superscript, which just means that it's a little bit smaller font, a little bit higher up, right? That's superscript, right? That means times 1,000. Don't drop your stuff. Okay. Sorry, I gotta fix this before I move on here. Back. We'll do 2 examples and then I'll stop. This is technically example 9. I did skip number 8 because it was redundant. Right, what will be an Ionic Greek sequence of numerals as the standard Hindu-Arabic system. I haven't been abbreviating this all this while. This is Hindu-Arabic. Okay, so let's just say, for example, this is also very stylized. you had tau, which I'm familiar with because I studied physics, and pi, which is like a tau plus 2, you know. And then epsilon. Really, you think of the ciphered system as like you need the secret key, you know, and this is the secret key, right? There are characters for, you know, there are numbers that translate this directly for each one of these. All right, so if you go here, look for tau, all right, I mean, it's somewhat alphabetized here. Yes, somewhat. Here's tau. It's 300. Right. So that's 300. And then pi is apparently 80. Here's pi. And then epsilon is 5. So it's really just adding. Right. Tau theta epsilon is 300 plus 80 plus 5, which is 385, of course. See if I can fit underneath here. Another example. If you had instead to convert from something that was a Hindu-Arabic numeral to Ionic Greek, here would be the example. If you had 1,654, right? All right. Take into consideration if you have something beyond the scope of the character set. All right. Again, here's the character set for Ionic Greek, the key, the secret code, if you will. All right. It only goes up to 900. So here's an example of where we would have to incorporate the superscript iota symbol. All right. We don't have 1,000. Right? We may have to use that. Maybe break it up into, again, since this is really just adding, right? Break into a sum. Which means 1,000 plus 600 plus 50 plus 4. This is 1,000, it's not 2,000. So we're going to need the symbol for 1 times 1,000. The symbol for 1 is alpha, right? To imply that we want to multiply by 1,000 would suggest that we use an iota symbol. This translates to that. Iota in superscript, alpha. For 600, there is a unique character. Here's the secret code again. 600 is chi, right? It's not chai, it's chi. All right. So this is chi. There's a unique character for 50, all right? Which, as you can see here, is what? It is new. Sorry, it's a little bit blurry. NU is new. It's sort of a stylized V, if you will. I believe it would translate to N, really, even though it looks like a V. Something like that. And then 4 is, I'm going to say delta. All right, here's delta. Lowercase delta is not a triangle, it's this sort of script shape. All right. And these in sequence a little bit closer together than the way that I have them written here. Iota, alpha, chi, nu, delta is the quantity 1,654. Okay. Let me stop here. We're at 12, there's some 15 minutes here. And let me give you some instructions. For homework, basically, you want to establish, a MAT-114 Mymathlab account. You want to do this as soon as possible, because you don't want to get your homework behind. Right? Then, ideally, again, look at the calendar for reference. If we covered section 4.1 today, ideally you would want to cover 4.1 before Wednesday. Now this is the first week of classes, so, and you may not have time to look at this until later in the week, but don't let it get ahead of you. You know, like if you're going to push it to any point, I would just say maybe Saturday. You know, you want to establish a MAT-114 MyLab account. It's more likely that you will just sort of extend the license that you have, but make sure that you are unique to either IN or IN1, depending upon which section that you're in. Okay? You should know which one of those that you're in, all right? Please don't choose the wrong one. I can't have you in a different class. All right? Do section 4.1 in MyLab. All right? Okay? All right. Thank you guys for sticking with me. Sorry about any talking over my sister here or whatever. I may end up having to move. I don't have a lot of, because I'm in my apartment, I don't know if I can even move. This thing is quite heavy. Alright, anyhow, I will see you again on Wednesday and maybe communicate with you between now and then. I'm definitely going to upload this video and then link everything in announcements. So make sure that you're looking at announcements on a regular basis, okay? Alright. Let there be light. All right. Take care. All right.